We are going to the moon, and we are going there to stay this time. So now we arrive at the big shift in NASA's vision. The United States, NASA, and partners around the world are committing to something much bigger. Building a place to stay and creating a permanent moon base will be far more challenging than simply landing astronauts. So if landing on the moon isn't the real challenge, because we proved we could do that decades ago, then what is? It's the next step. Actually building a permanent outpost, a tiny city on an alien world. And here's the catch. No one fully knows how this will play out. Still, NASA and its partners already have surprisingly practical, even innovative technologies that could make lunar construction possible. So, why is NASA suddenly aiming for the lunar South Pole instead of the safe, familiar equator where every Apollo mission once landed? Because this time the goal isn't convenience, it's discovery. The South Pole is a wild mix of impact craters, sharp mountain ridges, and ancient volcanic formations. And here's what makes it truly irresistible. Some of those deep crater floors haven't seen sunlight for millions or even billions of years. They sit in permanent shadow, acting like cosmic freezers that likely hold water ice delivered long ago by comets and asteroids. If we want long-term life on the moon, we need water. And if we want answers about the moon's history, this is the place. That's why Artemis is heading south, straight into the mystery. NASA has narrowed down 13 potential Artemis landing sites, and each one is a tightrope walk between danger and opportunity. These spots sit on thin rims of near-constant sunlight, just enough to power a future base, while everything around them plunges into deep icy shadow where water is likely hiding. It's a scientifically priceless region, but also one of the most hazardous places humans have ever attempted to live. So before we even think about raising a building on the moon, we have to face what is honestly the biggest enemy of lunar construction: dust. And not just any dust. This stuff is razor fine, ultra light, and sharp enough to slice through Apollo spacesuits like tiny shards of broken glass. It scratched helmet visors, it chewed up equipment, and it clung to everything it touched. So how do you build a city on a world where the ground itself wants to destroy your tools? Apollo 12 proved that the problem isn't theoretical at all. When the astronauts landed, their descent engines blasted dust so violently that it sandblasted the Surveyor 3 spacecraft sitting 180 meters away. That's why NASA knows we can't survive up there without real infrastructure. Now, in the short term, NASA does have a surprisingly simple trick for dealing with lunar dust, and it comes from the US military. Soldiers in Afghanistan used a spray-on polymer nicknamed rhino snot to solidify loose desert soil, turning soft sand into a firm, almost concrete-like surface that prevented dangerous dust clouds during helicopter landings. So, could we do the same thing on the moon? Technically, yes. It would stabilize regolith quickly and give astronauts a safe place to work. But here's the catch. Every drop of that polymer has to be shipped from Earth. That makes it unsustainable, extremely expensive, and it would leave microplastic pollution scattered across the lunar surface. Not exactly the future we want for a permanent moon base, so if rhino snot is only a temporary bandage, the European Space Agency is running an experiment called PAVER, and the idea sounds almost sci-fi at first. Melt the lunar soil into solid glass. Yes, actual glass roads and landing pads on the moon. And guess what? It works because lunar regolith is basically just sand, and glass is simply melted sand. This concept isn't even new. People were imagining it way back in C.Har 1933 as a way to pave deserts on Earth. Now the big question is, how do we melt all that lunar soil in the first place? One option is surprisingly simple: a giant magnifying glass. More specifically, a Fresnel lens about 2.5 meters wide that concentrates sunlight into a scorching beam. But because the South Pole sits in low-angle light, we may still need lasers to finish the job. And remember, this is slow work. Creating a 100 square meter, 2 centimeter thick pad takes 115 days. When we talk about building a real lunar city, we also have to ask, how will astronauts actually move around without spending half their day climbing in and out of spacesuits? The answer is pressurized rover vehicles, mobile habitats on wheels. Japan, working with Toyota, is developing a next-generation explorer called the Lunar Cruiser, essentially an RV built for the moon. It's designed to keep astronauts safe and comfortable for up to 30 days, letting them drive straight from one habitat to another without ever stepping outside. And powering all of this is a hydrogen fuel cell system, giving the rover long-range, clean energy, and the reliability needed for life in deep space. This is the first true car of our future moon city. So once astronauts reach the lunar South Pole, where exactly will they live? NASA's answer is something called the Foundation Surface Habitat, our first real home on the moon. And it's not a massive base, at least not yet. Think of it as a smart temporary starter house, a hybrid between a solid metal frame and an inflatable module. It's built for flexibility, quick deployment, and survival in one of the harshest environments we've ever attempted to inhabit. It's built across 3 floors, each one serving a very specific purpose, vital to long-term missions. The habitat can support up to 4 people, though typically only 2 will stay inside at any given time while the others explore in their pressurized rover. Level 1 is where every lunar day begins. It holds the airlock, the EVA suits, and a compact geology lab where astronauts can examine lunar samples before sending them back to Earth. Then they climb up to Level 2, an inflatable section that expands to give much more room. This is the floor dedicated to keeping the crew alive and functional, hygiene stations, exercise equipment for countering low gravity's effects, and a biological lab for studying how plants, animals, and even human cells react to the moon's extreme environment. And finally, Level 3 is the living zone, private sleeping quarters, a small kitchen, medical supplies, computer workstations, and even a human research lab where astronauts themselves become long-term study subjects. It's not spacious, it's not luxurious, but it's the first blueprint for humanity's foothold beyond Earth, a tiny home that marks the beginning of an entirely new chapter in human exploration. Now the foundation habitat can get us started, but it won't keep us alive on the moon forever. How do we build something tough enough to survive all of that without hauling construction materials from Earth? The answer might just be hiding beneath our feet, lunar dust. If we bake lunar regolith until it hardens into solid blocks, we can stack those bricks around habitats like armor. This outer shell helps with insulation, shields from cosmic rays. China, in particular, is pushing this concept forward with something called the Moonpot vessel, an egg-shaped habitat built using a blend of robotics, 3D printing, and traditional brick construction. It's a modern twist on ancient building techniques, designed for a place that has never seen a building before. To make it real, Chinese scientists created bricks using 5 different simulated types of lunar soil. Then, in 2024, they sent those bricks to the Tiangong space station. For the next 3 years, these samples will endure vacuum, radiation, and violent temperature swings as a real test of durability. A U.S. company called Skyports is developing a concept that looks like pure science fiction, enormous glass-blown spheres rising out of the lunar surface, and strangely enough, the moon might be the perfect place to pull this off. Here's the idea. Lunar soil, mostly sand and minerals, can be melted into a molten glass. On Earth, shaping that into a large structure would be nearly impossible. But on the moon, with no atmosphere and low gravity, you don't need much force at all. You simply heat the lunar dust until it turns into liquid glass, then inject a puff of compressed gas, and the structure inflates like a giant soap bubble. Skyports proposes building multi-layered domes, each layer separated by air gaps just like insulated windows. That design could protect astronauts from radiation, temperature extremes, and even small meteorites, all while creating vast open spaces inside. This isn't just a wild sketch on a whiteboard. NASA's Institute for Advanced Concepts has actually funded this idea for early research. It's experimental, ambitious, maybe even a little crazy, but if it works, the moon's first city skyline might be made of shimmering glass bubbles glowing under the stars. Now, even if we build roads, melt dust into glass, and raise entire neighborhoods out of lunar soil, none of it matters unless we solve one core problem: power. At first glance, solar energy seems like the obvious answer. After all, sunlight in space is strong and uninterrupted, right? Well, not on the moon, because the lunar day-night cycle lasts 2 weeks each. That means 14 days of complete darkness, followed by 14 days of bright sunlight. For robots, this has already proven disastrous. Lunar rovers powered by solar panels typically work well for one 2 week day, then freeze to death during the 2 week night. And even if they wake up again, they never fully recover. But here's the bigger issue. The South Pole, where Artemis and future lunar cities will be built, is filled with permanent shadows. Those same dark craters that hide precious water ice never receive sunlight, which is great for resources, but terrible for solar panels. So NASA has accepted a reality that seems obvious in hindsight. A real moon base cannot run on sunlight alone. The only scalable, reliable solution is nuclear power. That's why NASA is developing something called the Fission Surface Power System, a compact reactor designed specifically for off-world use. It must be small enough to launch, light enough to land, and tough enough to run for years. This is where Rolls-Royce, yes, the luxury car company, enters the picture. They've spent more than 6 decades building reactors for British submarines, and now they're designing space-ready microreactors capable of generating between 50 and 100 kilowatts of electricity. On the high end, that's enough to power a small factory or several modern homes. A lunar city won't need just one reactor. It could run on multiple units, linked together like a modular power grid. Nuclear power won't just keep the lights on, it will make a permanent moon settlement truly possible. So after all this, melting dust into roads, building brick-reinforced habitats, inflating glass domes, and powering everything with compact nuclear reactors, what does it all add up to? The answer is bigger than a base, bigger than a science station, bigger even than survival. It's the beginning of humanity's first real city beyond Earth. A moon city is not just a destination, it's a gateway.